Hello friends, welcome to ASTA Academy lecture series. Today we are going to start the second section, which is on advanced mathematics. Advanced mathematics consists of four different subtopics or sections: equivalent expressions, nonlinear equations in one variable, systems of equations with at least one equation as nonlinear, and the final one will be the nonlinear functions. So today we are going to start with algebraic expressions, and within the algebraic expressions, instead of having a one long lecture, what I've tried to do this time is I'll divide it into 4 5 small video lectures, hopefully less than 10 minutes each, and that will deal with different topics. Okay, so let us start with the first lecture on algebraic expressions. Okay, so I think you all must be familiar with this concept. What is an algebraic expression? Okay, it's nothing but it's a combination of numbers and variables, right? Combination of numbers and variables. For example, if we look at 3x square, okay, this is an algebraic expression. All right, why? Because it has number 3 and it has variable x, which happens to be in quadratic nature, which is power is 2. So this is an algebraic expression which has three distinct components. First one is called the numerical coefficient, which is a number. Okay, x is the variable here. So the second main component is the variable, which can assume any value within the domain. Okay, it can go from 0 to infinity or minus infinity to 0 or whatever. Okay, and this guy here, which is sitting on top of x, is called the power of the algebraic expression. Okay, so this algebraic expression, which I have written 3x square, because the maximum power is 2, we say it is quadratic. Okay, all right. Similarly, we can have another algebraic expression in which you have 4y cubed, all right, where 4 is the numerical coefficient, y is your variable, okay, and 3 is your power, okay, which happens to be 3. So that's why we say it is a cubic expression. Okay, now one thing I would like to stress upon here is, what is this 3.0? Is this a number or an algebraic expression? Well, it's a number, all right, but it can be thought of as an algebraic expression as well. Okay, now I would like to draw your attention to your number system. If you have x to the power 0, what is this is equal to? It is 1. What about 4 to the power 0 is 1. Any number n to the power 0 is 1. So we see that anything raised to the power 0 is always 1. Okay, so this 3 here, we can assume that this is multiplied by x to the power 0. Okay, so this 3.0 is an algebraic expression, all right, with power of 0. Okay, now this the 2 or 3 different algebraic expressions we have looked at just now, it had only one term. Only one term. In the first case, it was 3x square. In the second case, it was 4y cubed. Or in the last case, it was 3.0x0. So these are the expressions which has only one term. Okay? So one term type of expression is called monomial. Monomial means one term. If you have two terms, it's called binomial, two terms, and polynomial will have more than two terms. Okay. So now if I say 3x square plus 4y cube, what is this? This is a binomial. This is a binomial, but it involves two variables, x and y. What is the max power? Max power is actually 3. So whatever is the maximum power in an algebraic expression, that is called the power of the algebraic expression. Okay? All right. So now we have seen monomial, binomial, and polynomial, okay, and their examples. I'd like to give you an example of a polynomial, okay, in which you can have something like ax square plus bx plus 1. It has more than 2. So it is actually 3 terms. So 3 terms has again a special name which is called a trinomial, okay, and more than 3 you can say polynomial, okay. Then we can have what are called the rational expressions. What are the rational expressions? Well, we are familiar with the rational numbers like 2 by 3. Okay, so when we have an expression which has a denominator and a numerator, all right, expression on top, expression at the bottom, all right, that is called a rational expression. All right, examples could be x minus 1 divided by x plus 1 or something like this. Okay, so this is called a rational expression. Okay, now we come to a slightly different concept in which we say what are equivalent expressions. Okay, as the name of the topic suggests, equivalent expressions means we are looking at more than one expression and we are looking at their values. Okay, and the expressions will involve the variables. All right, and variables can assume any value. So if you put any value of x, let's say, into expressions and the value comes out to be same, then it's called the equivalent expressions. So expression, let's say 1 is same as expression 2, okay, for all values of x or the whatever the variable is I'm using as. This term is all values, okay, all values of x. So we have two expressions, all right. You put any value of x in both of them, their values will come out to be same. Now look at an example. You have 2 times x plus 3. Is it equal to 2x plus 6? Okay, they look slightly different, but essentially they are same. You can distribute 2x and 3, and you will get the expression on the right hand side. Now you can put, let's say, x is equal to 0 on left hand side. What you will have? 6 is equal to 6. You put x is equal to 1 on both the expressions. X is equal to 1 will give you 4 into 2 is 8. And on the right hand side, if you put x is equal to 1, it will be 2 plus 6, which is 8. So no matter what value you put in both the expressions, their values will be same. Such type of expressions are called the equivalent expressions. Okay. Another example I would like to give you, a slightly complicated one. Okay. Example, let's say this was 1. Now I'm giving you example number 2. Okay. 4x square minus 10x plus minus 24 is equal to 2 times x minus 4 and 2x plus 3. Okay, So these are the two expressions which are actually equivalent. You may not be able to see this right now, but in this topic of algebraic expressions, we will learn the techniques in which we can go from left to right. Given this expression, we can deduce or we can find out what will be the form of the product. This is sum of a few terms. This is product of few terms. All right, on the right hand side. We will also see the procedure to go from right to left. If we are given the product, how we can find the sum of different terms for the equivalent expression. All right. Now I would like to emphasize on why it is important to study algebraic expressions in SAT. Okay. In SAT, essentially, you will see 3 to 5 questions from this topic on algebraic expressions. Okay. That's why it is important. And what will it involve? It will involve various things such as multiplying and expanding the polynomial expressions or polynomials. So we are going to learn all these things, how we multiply or how we expand the polynomial expressions. We will also study factorizing polynomials. Okay. So here we had looked at an example. So when we go from left to right, essentially we are factorizing 2x minus 4, 2x plus 3. These are the factors. So we will learn the techniques. How do we factorize the polynomials? Okay. And by the way, these two topics are opposite of each other. Okay. You will be multiplying and expanding a polynomial, okay, from right to left. And then when you are given the expression in this form on the left hand side, we can find out the factors, which are the product. Number 3 is simplifying rational expressions. Simplifying the rational expressions. We'll be looking at that. Next thing we will be doing is applying the radicals and exponent laws or exponent rules. Okay, x to the power m and so on. Okay, there are different types of rules for different type of situations. So we'll be looking at that. And finally, we'll be looking at recognizing the equivalent forms. Recognizing the equivalent forms of your expressions, and we have already seen what are the equivalent expression we should be able to recognize. Okay, some type of questions will come on this topic. Okay, so with this, I think I would like to stop here. We have just introduced the concept of expressions, algebraic expressions, and what will be will be expecting in the remaining chapters. Thank you very much.